Good morning, students. I am Dr. Betsy Claribel, Assistant Professor, PG and Research Center of Chemistry, Jayarajanapakam College. So today we are going to learn about the first law of thermodynamics in this unit. So here we are going to learn about the first law of thermodynamics. It is a very important and interesting topic in physical chemistry. So here we go. So now the word thermodynamics implies the flow of heat. That is, we are going to learn about the flow of heat. The heat flows from one end to another end. For example, if we take a metal, the heat will flow from the hot end to cold end. So thermodynamics deals with the study of flow of heat. So energy changes accompanying all types of physical and chemical processes. So it is based on the three broad generalizations, namely the first, the second and the third law of thermodynamics. So there is no formal proof for these laws. So out of experience, the thermodynamical laws were proposed. So here when you see this picture, you can see when you heat a metal rod, so the heat is getting transferred from one end to another end, and that is mainly from the hot end to colder end. So far nothing contrary to these laws have been proposed. So in thermodynamics we actually consider the behavior of matter in bulk. So we learn about the macroscopic properties. So now let us see the scope of thermodynamics. So the most important laws of physical chemistry, including the Van 't Hoff law of lowering of vapor pressure, then phase rule, distribution law, chemical equilibrium, and the laws of thermochemistry, all are deduced from the laws of thermodynamics. So it is very important to learn about thermodynamics. Then it also helps to predict whether a given process or a chemical reaction is feasible under given conditions of temperature, pressure and concentration. So the feasibility of a reaction is said by the thermodynamics. So whether a reaction will happen or not is predicted by the thermodynamics. So it explains the feasibility of a reaction, and it also helps in predicting how far for a physical or chemical change can proceed before the attainment of equilibrium. So before attaining equilibrium, how far the reaction will proceed is explained by the thermodynamics. So it is very important to learn about thermodynamics. Then moving on to the limitations of thermodynamics, it is applicable to macroscopic systems and not microscopic system. So here we consider only matter in bulk. So for example, when we take our college, JAC, and your classroom, that is a second, for example, second UG. So here the matter in bulk represents the college. So college represents the matter in bulk. So in thermodynamics, we learn about the matter in bulk and not only your particular classroom. That is a second UG. So that is individual atom or molecule. So here we consider the whole. As a whole, we study about the matter in bulk. So it does not tell about the microscopic properties. So it is one of the limitation of first law of thermodynamics. Then it can only predict whether a given process, including a chemical reaction, is feasible under a given set of condition. So it does not tell anything about the rate at which the given process may proceed. That is, it does not tell about the speed of the reaction. It tells us only about the feasibility and not the rate or speed of the reaction. So it is one of the limitation of thermodynamics. For example, if you take water molecule, so you know that in the air we have hydrogen and oxygen. So we know that a general reaction, the hydrogen combined with oxygen to form water. But we do not know when does the water will be formed. So the feasibility is known. So thermodynamics tells about the feasibility. Okay, this reaction hydrogen and oxygen combines to form water. But when the water will be formed is not known. So by the help of an external application like by giving a spark, by giving light, you can convert hydrogen and oxygen to water. So the rate or speed of the reaction is not known. So this is one of the example telling that the feasibility of a reaction can be known from thermodynamics, but not the speed of the reaction. And that is, it is considered concerned only with the initial and final state. So now next we move on to the terminologies in thermodynamics. So the first important one is that you should know about system and surroundings. So a system is nothing but the particular or a specific portion of matter under study or under investigation is known as a system. So it is defined as any specified portion of matter under study which is separated from the rest of the universe with a boundary surface. So a system may consist of one or more substances. For example, in this picture you can see the system, that is the cylinder. Inside the cylinder you have gas. So here we are going to learn about the gas present inside the cylinder. So the gas is the system according to this picture. So it has a boundary surface, that is the surface of the cylinder, and it is closed by a piston. So the rest of the universe other than the system is called the surroundings. So now let us see about what is surroundings. So the surroundings, the rest of the universe which might be in a position to exchange both energy and matter with a system is called surroundings. So in simple cases, in the image you can see that the system, the matter under investigation is the system which is surrounded by the surroundings that can exchange both heat and matter with the universe. So that thing is called surroundings. So next you have to know what is boundary. So the boundary may be real or imaginary surface that separates the system from the surroundings is called boundary. So in this picture you can see that is you have taken tea or coffee inside a kettle. So here it has both a real boundary and imaginary boundary. The real boundary is the boundary of the kettle, and the imaginary boundary is that you can see on the top in between the inside the kettle, the surface in between the coffee or tea and the air inside the kettle. So this is called boundary. So boundary is the one which separates the system from the surroundings, and that boundary may be real or imaginary. Then we move on to the types of system. There are three main types of system, that is isolated system, then closed system and open system. So here you can see that there is a red color double-headed arrow and a blue color double-headed arrow indicated in this picture, and the blue-headed arrow indicates the exchange of matter with the surroundings, and the red arrow represents the exchange of energy with the surroundings. So in the open system you can see that it can exchange both energy and matter with the surroundings, and in the closed system you can see that it can exchange only energy with the surroundings, not matter, because it is closed. Then coming to the isolated system, you can neither exchange heat nor matter with the surroundings. Now let us see one by one. So first one is the isolated system. So a system which can exchange neither energy nor matter with the surroundings is called an isolated system. So here you have taken, in this picture we have taken a conical flask which is closed and also insulated. So it does not exchange heat nor matter with the surroundings. So such a system is called isolated system. Next one, this is the closed system. So a system which exchange energy but not matter with the surroundings, because here we have taken a cylinder and it is closed by a lid. So it does not exchange matter with the surroundings, but it can exchange energy. So such a system is called closed system. So the boundary is sealed and it is not insulated. Okay, it is only sealed. So here it can exchange energy but not matter with the surroundings. This is called closed system. Then coming to open system, here a system can exchange both energy and matter with the surroundings. So this system is said to be an open system. So here in this image you can see that we have taken a conical flask that is opened. We have not closed it. Okay, so it can exchange both energy and matter with the surroundings. Then moving on to the macroscopic properties. So the properties associated with macroscopic system, for example, consisting of large number of particles are called macroscopic properties, and the pressure, volume, temperature, composition, density, viscosity, surface tension, refractive index, all these comes under macroscopic properties. Then we have to know about the homogeneous and heterogeneous system. So a homogeneous system is one when it is completely uniform throughout. So from the name itself you can recognize that homogeneous means it is uniform throughout. Example, pure solid or pure liquid or solutions or mixture of gases. All these comes under homogeneous system. So system consists of only one phase. In homogeneous system it consists of only one phase. Then heterogeneous system, a system is said to be heterogeneous when it is not uniform throughout. So it consists of two or more phases. For example, a liquid in contact with vapor. So liquid is one phase and vapor is another phase. So there are two phases here and it is a heterogeneous system. And a solid in contact with liquid, then mixing of two immiscible liquids, for example oil and water, this system is said to be heterogeneous system. And ice in contact with water. So all these comes under heterogeneous system, more than one phase. Then extensive and intensive properties. So the macroscopic properties of a system can be divided into two classes, that is intensive property and extensive property. So intensive properties, a property which is independent of the amount of the substance. So from the name itself you can say when it is intensive property, it is independent of the amount of the substance. So here it is independent of mass and size. For example, pressure, volume, temperature, composition, density, viscosity, then surface tension and specific heat. All these comes under intensive property. They are independent of the amount of the substance. So for example, if you take water, so the density of water here, you have to know that if you take 200 ml of water, the density is 1, and also it may be 200 ml or 300 ml, then 1 liter or 2 liter, how many liters you take, the density remains same. Always the density of water is 1. So this density comes under intensive property because it is independent of the amount of the substance. Then moving on to extensive property. So a property which depends upon the amount of the substance is called extensive property. Here it depends on the amount of the substance taken. So it depends on the mass or size of the system. For example, mass, volume and number of moles, all these comes under extensive property. So in the picture to your right hand side, so you can see that weight. So weight depends on the amount of the substance. So if you take less amount of substance, so the weight will be less. So all these comes under extensive property, and also the length and volume. So hope you understood so far. Thank you. We can continue in the next video. Thank you.